That's what we just tested on. This is an exponential equation, and the way we solve it is to make our bases what? Equal. And once our bases are equal, then we make our exponents equal. True? All right. We should be able to work this without doing it, but let's do it the long way. 64 is 2 to the 5th power. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times you're right. Gosh, I hate being wrong.
I love being right.
So what's the value of x? 6. So when we evaluated log base 2 of 64, the answer is 6. You don't have to say x equals 6, but the answer is 6. Okay? Does that make sense? So why did we have to learn this before we can learn this? Because we have to do this to be able to do this. All right? And we took it one step at a time. Let's evaluate another log. Log base 4 of 256. All right. First, we have to know what that looks like as an exponential equation. My base is 4, my exponent is x, and my solution is 256. Now, reverting back to solving these things, I have to make my bases the same. I can probably turn this into 4 to the something power. And the use of a calculator would be really good.
It's 2 to the 8th.
It's 2 to the 8th? Okay, well, if we know that this is 2 to the 8th,
I think it's 2 to the.
then this is 2 to the 2x, right? Because our bases have to be the same. So now, if my bases are the same, then I'm going to focus on my exponents being the same. Without setting this up and solving, what's the value of x? The value of x is 4. Okay, I want you guys to see if you can figure out what log base 2 of 1/8 is equal to. You're going to have to watch this lesson online tonight. Because you can't come in at this point and get it. Yeah. So what I'd do if I was you is just go ahead and write all the stuff down, and then tonight go back and get the intro.
I missed the answer to the last one. What was it?
4.
Is the golf team still out?
Yes. Does someone have a solution yet? It's not -1. It is negative, but it's not -1.
It's -3.
-3 is correct. The base is 2, the exponent is what I'm looking for, and 1/8 is the solution. Back to what we were just doing, last test. We've got to make our bases the same. Right now I've got whole number versus fraction. I've got to start by turning this into a whole number, which will give me a negative exponent, right? Then I've got to make my, you stopped. Now you've got to make your bases equal. 8 is 2 cubed, and 2 cubed to the -1 is 2 to the -3. Now that my bases are equal, I need to make my exponents equal, so x has a value of -3. The solution here is -3, evaluating a logarithmic expression. All right, now, watch the confusion when I write this down, but how simple it is.
That's just me.
Well, it's something we have to see, though.
We have to see it.
What's up, Rob?
Yes.
Yes, that's the reaction I was expecting. Okay. Orland's face is just dumbfounded. Okay, let's break this down real carefully. Okay, this is a base raised to an exponent, correct?
So that means that it's the,
And in the exponent, I've got a base,
So 8 is.
correct? Okay. These are inverse operations of each other, sort of like the square root of 10 squared. I'm raising a base to an exponent that contains that same base
so it's just.
in the exponent. So it's an inverse of each other. What happens when you take a square root of a square?
You cancel
It's
it out.
They just go away and you're left with 10, right? Well, if my bases are the same, the base here and the base here are the same, they cancel each other and all I'm left with is 10.
Is it log to the 10th power? or
It's
log
just
to the
10. It's just 10. The answer is 10. They are inverse operations of each other and they cancel each other. That's one way to write it. Here's another way that it could be written. Oh, what is another way that it could be written?
5 to the 5th times the 1/5.
5 it can be written 1/5 to the negative log 15.
Here's another way it could be written. It's log base 6 of an exponential expression with a base of 6. If these bases are the same, they are inverse operations of each other, they simply cancel each other and all you're left with is
A squiggly
8. And so the solution is 8. Not 8 as an exponent, not the log of 8, not 1/8, but
8.
8. Okay, so as confusing as it seems, it's not.
No.
It's very, very simple.
Simple.
All right, so let's take some of these and make sure you can come up with the solution to it.
Let's call it a day.
I don't think I could do it.
Not yet.
Okay.
I just did that one. And I did that one. I'll just make some up. Okay. Okay, let's look at these two.
No.
Am I on screen?
No, because your logarithms is wrong. No, we forgot to remind you. You have to see what.
I'm a little over. I'll adjust. Okay, there we go.
We're experiencing some technical difficulties.
Shout out to Rob.
We've got a triple level thing going on here, really. Okay? But this is a base with an exponent, and this is the base of the logarithm. And if the bases are the same, what's the value? What's the solution? 2.
2.
What's the solution there?
6.
6. The base of the logarithm and the base of the exponential are the same. So the answer simply is 6, because they are inverse operations of each other. And so they undo each other. Okay? That's what we're doing in this lesson today. Tomorrow we're going to take logarithms, the rest of this, and we are going to actually solve equations involving logarithms and inequalities. So the homework tonight's on the board over there. I'll write it here for anyone viewing at home.
Hey, we got this, John. There's this battle in the Pacific, and
Hey,
the Japanese
hey,
had 3,000
hey,
people, and
hey.
only 17 were captured. The rest died.
All right, let me explain the homework.
Put them open.
Hi, Rob. Where's Rob going to be today?
On there.
Oh,
Who's Rob?
okay.
Ramon.
Okay, shh.